When you're about to do a complex task, the best approach is to break down your complex tasks into series of simple tasks. Then you can combine your simple tasks together to form the complex tasks. The process of breaking down a complex task into series of simple tasks is called differentiation, and the process of combining small tasks together to form a complex one is called integration. Differentiation, breaking down; integration, bringing together. You're welcome to this channel. In this video, you are going to learn integration, and this is just the first introductory video to learning integration. In our previous video, we have looked at differentiation, so here we are learning integration. Without further ado, let's start the class. If you are to integrate a function, integral symbol will be shown followed by the function as seen. Now, if the function is definite, we are going to have the limit, upper limit followed by lower limit as shown. Now, let's learn the conceptual meaning of integration. So let's have this cylindrical shape, a solid shape as shown here. This cylinder is having a radius. Now, let's just imagine you want to form this cylinder from a circle that is having a radius r here. Okay, let's say you are starting from, let's start from the base here. Let's have this cross-sectional area, which is a circle. Okay, now you can have the area of the cross-section at the base, which is pi r square here. This area that you have picked from the base, you can start adding it up, starting from this point up to this point to form this cylinder. So when you start from this point here, you move upward like this. So from here to here, you are going to have the height, the h. So which means this point will be 0. This point will be what? H. So let's apply the knowledge of integration to find the volume of a cylinder. Now, so which means that you are integrating pi r square along which direction? From 0 up to the point at which the height is h. Okay, now what are you integrating now? Along which direction? H. So you are going to do have what? dh here. It's as simple as that. So you have the h. So when you solve this at the end of the day, so this thing, every other thing that is not h becomes a constant. You have pi r square with comma. Don't worry, we are still going to learn this. Now I have h here, you have 0 here, you have dh here. So you have what? When you integrate the h, you are going to get h. You have pi r square outside, you have this, you have your h here, upper limit, 0 here, and then you have your h here. At the end of the day, you have pi r square h minus, when you insert the value of the limit, minus pi r square multiplied by 0. So you just insert h here and you insert 0 here. You subtract. When you do this, you get pi r square h. Now, this is the conceptual knowledge of integration. So let's start learning standard integral, just like differential. Standard integral is just the opposite of standard differential. We have many of them, so we are going to look at just few here. The basic one you need to understand. Okay, when you understand differentiation very well, you will not find integration, you will not find it difficult. The first one we are going to look at is this function, which is when you have dy. The standard differential for it is you are going to get y. It's very simple. So when you integrate dy, you are getting y. When you integrate dc, you are getting c. dt, you are getting t. dA, you are getting a. So this is the standard differential. Now another one is when you have a constant. A constant means number, a number before your differential. So c dy, when you integrate the whole of everything, you are going to get cy your constant multiplied by the variable. The next one, when you integrate this function is a what? Polynomial function. When you integrate it, it's just like the inverse of differentiation. So we are going to get this ax raised to the power n plus 1 divided by n plus 1. You just add 1 to it, this power here, then you divide it by n plus 1 when you add 1 to the power. You see that is like the inverse of differentiation. The next one is sine x. Okay, sine x. Sine x dx. When you differentiate it, it's very simple. Differentiation of sine x, you are going to get what? Cos x, isn't it? But integration of sine x, you are going to get minus cos x. Don't get yourself confused. When you differentiate sine x, you get cos x. When you integrate sine x, you get minus cos x. So which implies that when you now integrate minus sine x, you get cos x. The next one is cos x. Very simple. So when you differentiate cos x, you get what? Minus sine x. Oh yeah, let's go. When you differentiate sine x, what are you getting? Is it not cos x? It's cos x. Now, when you now integrate cos x, what are you going to get? Is sine x. Very simple. You get sine x. The next one is sec square x. Oh yeah, let's go back to differential. When you differentiate tan x, what are you getting? When you differentiate tan x, we get sec square x. So when you now integrate sec square x, what are you going to get? Tan x. Let's look at this 1 over x. When you differentiate ln x, that is the natural logarithm of x. When you differentiate it, we get 1 over x. The same thing is applicable when you now integrate 1 over x. What are you going to get? You get ln x. Finally, exponential x. This one shouldn't be hard. When we differentiate exponential x, we get back our exponential x. So which means that when we integrate exponential x, we get what? Exponential x. It's very simple. Let's look at the first example here, which is integrate 1 over x plus 4x squared minus 3x raised to the power minus 2 with respect to x. So this one is very simple. What we just need to do is we need to apply our standard differential very fast. Now let's solve it very fast. Let's have a solution here. Now looking at this is what he asks us to do. He has to integrate 1 over x plus 4x squared minus 3x raised to the power minus 2 with respect to x. So which means the x is going to be here. Now to solve this expression is a polynomial function, polynomial expression. What we just need to do is, you see this integral sign, you use it to expand the whole of this, then you multiply it by dx. So let's go. So we are going to have integral of 1 over x dx plus integral of 4x squared dx minus integral of 3x minus 2 dx. So it's forming shape. The next thing to do here is, let's now start integrating this one after the other. Now, what is the integral of 1 over x? Is it not ln x? So we have ln x here plus. This one is what function? Polynomial function. So we are going to have what? Plus 4x raised to the power 2 plus 1 over 2 plus 1. This one minus, what about this one? 3x raised to the power minus 2 plus 1 over minus 2 plus 1. Okay, this one is settled. We have ln x. Finally, you are going to add plus constant here. So when you integrate, you are going to add constant, because while differentiating, you might have some numbers that when you differentiate them, they are 0. So we don't know. So that is why we used to add plus constant after integrating. So you have ln x here. This one will be what? Plus 4x raised to power 3, 2 plus 1 over 3. Okay, now this one will be 3. You have minus here. What is minus 2 plus 1? That is minus 1. So minus 1 here. Then you have minus. It becomes plus. Plus. So you have 3x raised to power minus 1 over 1. Minus 2 plus 1 is minus 1. The minus will divide this minus and it becomes plus. It's not hard. Plus c. Finally, let's write our expression. We have ln x plus 4x raised to power 3 over 3 plus, you can bring this one down, 3 over x. X is power minus 1 is 1 over x plus c. As simple as A, B, C. Let's move to the next question. So the second question, which is simplify integral 7t cubed plus 4t with respect to t. How do we solve this? It's not the time that you'll be seeing x and y. So here we have t. So we want to integrate with respect to t. So let's have a solution here. So we have a solution. So what do we want to do? We want to integrate this 7t cubed plus 4t with respect to t. So to do it, you can also apply what we have done earlier on. 7t cubed dt plus integral of 4t dt. So you have, listen attentively, this 7 here, which is a constant, can come out. So you have t cubed dt plus, the same thing applicable to 4. 4 can come out. T dt. Yeah, let's solve it. So you have 7 open bracket. When you integrate t cubed with respect to t, so you're going to have what? T raised to power 3 minus 1 over 3 plus 1. You're done with this. Let's have it close. Plus. So you have 4 open bracket t raised to power what? 1 plus 1 over 1 plus 1. You're asking me, where did I see my 1? It's very simple. T is still t raised to power 1. Now you add constant plus constant. So you have here 7. What is t? 3 plus 1, 4. 7t raised to power 4 over 4 here plus t. 1 plus 1, 2 here. 2 divided by 4, 2. So you have 2t. 1 plus 1 here, 2 plus constant. Constant. It's very simple. Now let's see how to solve the third question. It's not all the integration that is straightforward like we have been solving it. It's not all the integration or integral that are simple and straightforward. Now, we have different techniques of solving or integrating expression. And here we are going to look at some method. The first one is called integration by substitution. So we want to link our previous knowledge with integration here. Okay, let me quickly give you a clue where this is coming from. Now let's go back to differentiation. Let's say you want to differentiate y is equals to 4x plus 7 everything all raised to power 10. Now you discover that to differentiate this kind of expression, it will be very difficult because you might want to expand 4x plus 7 raised to power 10 and you are going to get something that is so large. So to do that, you can use Pascal triangle or you use the knowledge of combination to expand this very fast. Then you can now start differentiating them one after the other. It will take a lot of time. So instead of doing it, you can differentiate it as a whole using chain rule, which is substitution. You are going to do what? You are going to say, okay, you is equals to what? 4x plus 7. So you can now do what? Du dx. You differentiate u with respect to x. So you are going to get 4. You remember, since u is equals to this guy, you now say y is equals to what? U raised to power 10. You can differentiate this one with respect to y. You say dy du. You get what? 10u raised to power 9. What are we looking for? Dy dx. And we're able to see that dy dx will be the same thing as what? Du dx times dy du. You can now say 4 times 10 u raised to power 9, which is 40 u raised to power 9, and you get 40. What is u? U is 4x plus 7 raised to power 9. You have been able to solve this without expanding this. So let's see the first example here, which is simplify 7x plus 4 close brackets all raised to power 6 dx. How do we solve this? This is very simple. Okay, we want to use integration by substitution method. So let's have a solution here. Solution. What do we need to substitute for here? We need to substitute for this guy here. We need to substitute for this guy here. Let me show you the reason why we need to substitute for this x, for this dx. Okay, let's start from 7x plus 4. You can say this is what we want to do. Let's just write it first. We have 7x plus 4 raised to power 6 here, x. So you say what? Let's just divide this into 2. You say let u. You can use any alphabet. Just make sure it's not x. U is equals to 7x plus 4. Here, it implies that du over dx is equals to what? 7. When you differentiate this one, you get 7. Go back to the question. You have dx here. We want to substitute for dx. So which means from here, you need to make dx solve the formula. So this one is du over dx is equal to 7 over 1. Convert this to fraction. You can cross multiply as usual. So which means 7 dx is equals to du. Finally, what will now be dx? Dx is equals to du over 7, which is still the same thing as d times 1 over 7. You can use either of that. Now go back to the original question and substitute. Where you see 7x plus 4, what are you going to put there? U. Where you see dx, what are you going to put there? Du over 7. Okay, so original question will now be like this. U raised to power what? 6 times, let's just use dot for times du times 1 over 7. Let me say something here. When you are integrating with respect to x here, what differential follows it? Differential of x. So they must align. So if you are integrating y, what must follow it? dy. So if you are integrating c, what must follow it? dc. If you are integrating u, what must be here? du. So we have our du here, so we can integrate this du. Now everything that is not u, it becomes what? Constant. It can move out. Okay, so which means that this one will also be what? 1 over 7 integral of what? U raised to power 6 du. Let's go. When you integrate this, you are going to have 1 over 7 multiplied by u raised to power 6 plus 1 over 6 plus 1. Everything here plus constants. So let's finish it up. So you are going to have 1 over 7 times u raised to power 7 over 7 plus constants. So you are going to have what? U raised to power 7 over 49 plus constant. What is u? U is what? 7x plus 4 raised to power 7 over 49 plus constant. Some students are funny. They now say 7 year 1, 7 year 7. That's blunder in mathematics. If you do that, you get 0. Instead of expanding this binomial expression using Pascal triangle or using combination and permutation before integrating, so we are able to integrate it without going through that stress. Okay, this is how to solve question using integration by substitution. The next question.
That will be our next video. If you haven't subscribed to this channel, kindly subscribe to this channel and click on the notification icon to get notified when new video is released. Subsequently, we are going to learn some other techniques. Make sure you watch the next video now.